So today we're going to talk about electronegativity and bond characters, mostly the periodic trends, what bond characters are, the difference between covalent and ionic, and also polarity, which is nonpolar and polar. So first, we're going to get started with electronegativity before we get into anything else, because it's the most broad part about this, and it also directly relates to everything else we're going to talk about. So let's get started. Electronegativity, that is the tendency of an atom in a covalent bond to attract bonding electrons, and it increases across a period and decreases down the groups. So let's say you have group 1A here, you have hydrogen at the top, and that is the most electronegative element in that group because it's at the top, and as you can see, the electronegativity gets smaller as you go down. And then francium, which is at the bottom of group 1A, is the least electronegative element in that group because once again, it decreases as you go down the group. Now let's take a look at a period because periods increase instead of decrease. So for period 2, you have lithium, which is the least electronegative, and then you have fluorine at the other side of that, and that is the most electronegative in that period. So as you can see from this little picture I have here, francium is the least electronegative element in the periodic table because it's in the left-hand side, it's at the bottom of its group, and it's at the beginning of its period, so it has the least amount of electronegativity. And then the opposite is for fluorine, which is the most electronegative element. Because it's the most electronegative, it's more likely to bond with other elements in the periodic table, which you will see throughout the class. So I have a practice question for you. Which element is more electronegative, lithium or sodium? I'll give you a minute to think about that. So if you said lithium, you would be correct, because lithium is higher in its group than sodium is. So let's take a look at our next thing, which is bond character. So bond character is how covalent or ionic a bond is, using the bond length and difference in electronegativity. We're focusing on the difference in electronegativity because it relates to polarity and how polar a covalent bond is. So a small difference is covalent bonds, which is what we're going to talk about next. And then large differences are ionic bonds, which we'll talk about at the end. And then I have a quick practice question for you all. Will sodium and chlorine make a covalent or ionic bond? I'll give you a minute to think about that. If you have a periodic table, you can get it out if you think it'll help you. All right, if you said ionic bond, you would be correct. Because of the large difference in electronegativity between sodium and chlorine, because they're on opposite sides of the periodic table, the difference in electronegativity is high, making it an ionic bond. So let's move on to nonpolar covalent bonds. So as you can tell, covalent bonds are bonds that share electrons. And so this nonpolar covalent bond occurs when two atoms share a pair of electrons with each other equally. Now this equally is super important because it is such a difference between nonpolar and polar bonds. So a good example of this would be hydrogen gas because they equally share their electrons. And then if electronegativity difference is less than 0.4, the bond is nonpolar. So when you subtract the two elements from each other, the difference should be less than 0.4 for it to be nonpolar. And then I have a quick practice question for you. Is oxygen gas polar or nonpolar? If you said nonpolar, you would be correct because oxygen gas equally shares its valence electrons and making it nonpolar because there's no unequal poling on either side. So then we're going to move on to the opposite of nonpolar, which is polar. And this is a bond where electrons are unevenly shared, and that is caused by a large difference in electronegativity. Now, electronegativity differences are greater than 0.4, But also, that's not mentioned on here, but they should be less than 1.7, because after that point, it's no longer covalent. So it has to be a larger difference than 0.4 and less than 1.7. A good example of this is water, because it unequally shares, and it contains those dipole moments, making it polar. And as you can see here in our little picture, the atoms are distorted because they're polar and they're each pulling unequally at each other, and they create these dipole moments. And then I have a practice question for you. Is HCl a polar or non-polar molecule? I'll let you think about that for a moment. So if you said polar, you would be correct. Because this is a more electronegative, it does not equally share the bonding electrons with hydrogen, and it keeps that pole that you can see in that picture. Next, we have ionic bonds, and this is the complete transfer of valence electrons. We kind of talk about this in honors chemistry and stuff like that. And it's typically opposingly charged ions, like that metal and non-metal bond between like silver and fluorine and stuff like that. And then this contains lattice energy, and that is the amount of energy that's needed to separate a mole of ionic solid. And this is the last thing we're going to talk about, so I have one more question for you. Is AgCl an ionic compound? I'll give you a minute to think about that. If you said that this is an ionic compound, you would be correct. Because they are a non-metal and a metal, that's an ionic bond. And there's also a very large difference between electronegativities in Ag and Cl. So that makes it an ionic compound. So that's the end of what I have for you guys today. We talked about ionic bonds, polarity with covalent bonds, bond characters, and electronegativity. Now you have to remember, electronegativity is within all of these because you can define polarity with the difference in electronegativity between the elements. And that's really important because you can tell that from the periodic table. And you can also kind of, as you get more familiar with the periodic table, you'll be more familiar with like kind of where these elements are, especially the common ones that are used like chlorine and fluorine and stuff like that. Especially sodium. Sodium's used a lot as well. And then all of this stuff is going to relate to stuff you learn later, especially polarity and those dipole moments. And overall, that is all I have for you.